Let me formally invite you, sir, to the session. Uh,
Thank you.
uh, Good afternoon, everyone. Myself, Dr. Hamza Nassi from Bharat University. It is a great honor for me to introduce today's speaker, Dr. S. Gomati Naigam, sir. He has completed his uh, BE Civil Engineering from NIT Trichinapalli, Madras University, and then he has completed his MS in Structural Engineering from IIT Madras and PhD in Ocean Engineering from IIT Madras in 2005. Afterwards, he started working with the Structural Engineering Research Center, Chennai, and then he moved to National Institute of Wind Engineering between 2009 and 2017. And then he is working as independent consultant and project management advisory for since February 2017.
Yeah.
He has won many international fellowships such as DAD, and was and he's a very accomplished uh, researcher, and he has visited to many countries for his talks. And now, sir, I give this podium to you for your talk to start.
Thank you, Hamza Singh. I will thank you for the good introduction. I'll just share my screen. The technical hitches are there always. Okay.
No, no problem, sir. No problem.
Emerging trends in aerospace engineering. I'm just going to cover these 5 points essentially: AI-driven autonomous aircraft systems, sustainable aviation designs powered by AI, advanced predictive maintenance using digital twins, and spacecraft mission planning and simulation, real-time air traffic management systems. Okay, why we explore emerging trends in aerospace? If you just take an overview of aerospace engineering as a cutting-edge domain today, it is one of the most multidisciplinary engineering and physics with complex scales to be followed in the simulations. Scales, what I mean is, if you want to simulate a, a, a PowerPoint board, PCB board, it will be in nano. And if you want to simulate certain uh, wires, and it will be micro. Some dimensions would be in micros. Some dimensions like aircraft dimensions, wing and door and propellers, it could be in meters. And when you think of the space the aircraft travels, it will be in hundreds of kilometers or thousands of kilometers. So you can imagine what are the complex scales one has to deal with if you want to completely bring in the model from design to prototyping, commercializing, and operational. So the scales involved are very complex scales, starting with nano to thousands of kilometers. That's why it is so complicated. That's why we are exploring more and more technology into it. So we will deal the emerging trends on a generative AI and digital twins, which are uh, the opening, it's an upcoming area in many sectors, not only in aerospace. But we'll discuss, but today's discussions will be with respect to aerospace. What is generative AI? It is not a big rocket science. We solved earlier uh, decision support systems. We kept data inside the program and used the if then else logic, and then built in some decision making capabilities using Prolog and such languages. That is called expert system. Then knowledge based expert system came up. Then we moved on to artificial neural networks, where we try to simulate human brain actions. And then big data was available. We were able to map the input and output through deep learning with the multi-layer networks, fuzzy logic and everything built in. And that is ANN and neural networks. With deep learning, you are able to generate AI by prompting and feedback, prompt engineering and feedback. You are able to create a human-like software tool, like just like ChatGPT, okay, which will generate new content for you. It could be text, image, or design, or even another chatbot, ChatGPT, with a specific task orientation. They are called chatbots and uh, or agents today, modern terms. So this generative AI is nothing but an AI machine, software and this thing integrated, data learned AI machine, which can generate new content based on prompt and feedbacks. So it can be used for predictive and prognostic designs, analysis, operations, and maintenance. Okay, then what is digital twins? Digital twins is nothing but digital twins. Don't think it is a hardware, it is a software platform. It is just not a software platform alone. It requires a hardware which is exact replica of the digital system. A physical hardware is a must, and a replica in the digital system is called digital twins. They both together form the digital twins. So it is not, again, so difficult to imagine. Uh, you go for a cataract eye operation. I got both of my eye cataracts done. In 5 minutes, it's done now. Robotic, a digital twin approach is directly used there straight away. The doctor sees in the system and operates the lens and fixes the lens in 2 minutes, 3 minutes. Okay. So it's a simple example. I try to give you what is a digital twin. Okay, let's go. What is generative AI? The textual definition goes AI models that can create content on its own, text, images, designs, code generation, even programs it can generate, codes it can generate. Applications aerospace are plenty, autonomous system design, unmanned aircrafts, and predictive maintenance insights, enhancing human machine interfaces, AI generated aircraft designs. Then other applications are where AI is very much involved in aerospace engineering, using AI to improve flight simulation model for better accuracy and realism, using AI to develop intelligent air traffic control systems that can optimize airspace utilization, reduce delays, okay, in any airport, and using AI to improve weather prediction models for better flight planning and safety, intelligent air traffic control, using AI to develop intelligent flight control, similar to driverless cars that can automatically navigate, operate aircraft. Autopilot is already operational, using AI to optimize airspace utilization and reduce congestion, using AI to predict equipment failures and reduce maintenance downtime for aircraft, using AI to develop new materials for aircraft construction that are lighter, stronger, and more durable, using AI to develop intelligent spacecraft and robots for space exploration missions. So the application of generative AI is a good list is there. Then what are digital twins? A digital replica of a physical asset, system, or process is called a digital twin. Components, a real-time data from the physical asset, which could be aircraft, system, or any process, manufacturing process. And simulations, which are digital twin of the physical system, and IoT integration, Internet of Things integration, makes it the digital twin is workable. Applications in aerospace are plenty. Aircraft performance monitoring. During the flight, data will flow to the ground station through the cloud, and you will learn a lot of things what happened during that flight from London to India. Virtual prototyping, operational efficiency, and so on. Digital Twin Consortium works at now. The areas of digital twins is very much advanced now to tackle aeronautics, advanced rotary and mission systems, missiles and fire control, and space technologies. So the Lockheed Martin has formed a digital twin consortium, and which will look into future partnerships from industry, aerospace and defense, non-aerospace and defense, and US as well as non-US counterparts and academia from various areas. So there needs to be digital twin standards, okay, and it is under development. Digital twin development strategies are coming up in a big way, because if you take any digital twin in aerospace, there are so many things which are done outsourced. So I will be covering two videos from which I learned quite a lot in this domain. How data science is transforming by Patwanabhan, is a NASA scientist, former ISRO scientist, and then by Karen Wilcox, who is a professor and HOD of Center of in the University of Texas Austin. So those videos would give you a excellent overview of what is digital twins and GenAI applications together. So in this, you find not only in aerospace, even in cardiovascular treatments in health sector also, digital twin plays a vital role today. And digital twins has to be standardized. Why? Because you take any original equipment manufacturer of the aircraft, whether it is Boeing or any other company for that matter, many parts are done in many countries, in many companies, and they are system integrated at one place. For instance, the Boeing 787 parts are done in China, Japan, Canada, England, Sweden, France, Italy. Maybe some doors are being done in NIL, Bangalore also. Okay. So there is a need for standardization of digital twins, so that every part that is made from anywhere in the world fits into the original conceptual design of the aircraft as originally visualized by the designers. Okay, so there is going to be a standard for interoperability of digital twins between the supply chain management and spare parts. Right. Obviously, though we are not going to talk about it, applications in space technology is enormous, because every experiment will be so costly, one cannot afford to spend the entire prototyping to learn things. So a digital twin allows you to learn from the digital version, simulate by simulation, and get the optimum which can be prototyped and commercialized. Right. So digital twins in aerospace today has started at concept level for the entire life cycle of any aircraft. It is available. For in design stage, just virtual prototype is available in system, which will be exactly similar to the one which is flying between London to Paris and so on. Okay. And manufacturing, operation, and post life supply chain, O&M, operation maintenance issues, then retirement after the completion of design life. So this AIA Institute position paper defines, after going through all the literature available in this sector, a definition which is: a digital twin is a set of virtual information constructs that mimics the structure, context, and behavior of an individual unique physical asset, which is dynamically updated with data from its physical twin throughout its life cycle, and informs decisions that realize value through simulations. So this is one of the definitions which are most appropriate for the digital twin in aerospace. Right. So artificial intelligence in original equipment manufacturers are they are using even surveillance. I mean, life-saving drones are being designed with the AI and digital twins, and micro robots which are used to monitor aircraft performance, predictive maintenance. Micro robots are miniature robots which are again intelligent to capture defects, identify and manage the risk. Like the Tamil movie Yandran, you know, drones can be disintegrated and assembled together for efficiency. So these are all possible with digital twins technology. The entire engine design, starting with propeller to the operation of that, there is the physical asset, there is the digital asset. So there are plenty of applications in aircraft component and system suppliers at supplier level. That's why standardization is going to be there in soon. Okay, in brief, what is the concept of digital twins in aerospace? What is the big technology there? One is a digital state, parameters like model inputs. Another is a physical state, which is parameterized state of the physical asset. Okay, so geometry, structural parameters, engine parameters, boundary conditions, similar thing which are happening in the physical state of the aircraft during design stage and operation manufacturing stage everywhere. So at every stage of conceptual to operation, you need to have control inputs for decision making and actions, in-flight maneuvers, maintenance, inspection decisions, sensor installations, and so on. In addition, that will be supplemented by the observational data. For instance, one half of this is physical, one half of this is symmetrically digital. Okay, so which means it will be almost one to one. Okay, then we have quantities of interest, which is like fatigue, crack, or remaining useful life, failure stress, hot spots, and so on. And if you manage from observational data and control inputs from digital simulations, you will be able to set right issues much in advance so that the mission success is happening. Optimum fuel will be burnt and maintenance will be or inspection cost will be reduced. This is the very purpose of digital twins. Okay, how does the digital twin work? You have the physical space at any time t equals 0, you have a status. At there is a status S1 with an incremental, and by comparing these and what was intended, then you can compare and learn quite a lot of, because volumes of data will be used from this state to this state, input to output. So there is a learning there inside. And similarly, S2, there is a learning between S1 and S2. So the digital space can predict well in advance before the physical asset reaches that t equal to 4, so that it will be well prepared to manage turbulence, incoming turbulence, the aircraft, everything, the manuals will be automated. So that is the purpose of digital twin in aerospace. So as I told you, digital twin requires for calibration everything a hardware. So this particular digital twin done by Karen Wilcox, where she has done a lot of fundamental research on digital twin technology. She had a 12 feet telemaster aircraft which was customized for validating the digital twin software which she developed and her researchers, which means creating, evaluating a structural digital twin would involve calibrate geometry first, baseline model, calibrate geometry, calibrate material properties, mass and damping, and calibrate the digital twin. When you are ready with the digital twin, dynamic estimation of structural health can be done, and dynamic data comes from physical asset and it's a feedback. Then you can continuously update, you keep learning, and realistic aircraft will be simulated inside the system. And similarly, a structural model means a finite element model. Again, you would know, all of you would know very well, you cannot measure at all points in an aircraft. That will be huge mass of sensors, right? So you measure at critical points, but those critical points have to be modeled by reduced order model by static condensation, but it should be extrapolated in the digital domain to every point in the aircraft wing. Okay, so a measurement in critical point will indicate what's happening to the other points in the aircraft wing. So that is achieved through static condensation reduced models. Right. In short, digital twins in aerospace would be a domain knowledge and scientific machine learning, uncertainty quantification, explainability, optimization, decision making, scalable data simulation, predictive physics based as well as simulation based models. High performance computing is must, and obviously spaceships and other things would be very much benefited for space stations and so on by using digital twin approach. Digital twin also makes the in-flight testing a lot more sophisticated and reliable, and experimental flight test to verify and refute aeronautical hypothesis, a new innovation, testing a new aerodynamic design is possible, and development and certification of a flight test. Flights require a lot of safety level, and certification for flight test is a must at all operating conditions. So to evaluate the aircraft systems performance and safety, you can do development, and certification tests can be digital twin managed. And production flight test, validating production aircraft before delivery to customers and during even operational use, the digital twin can be useful. Today, if a flight travels from New Delhi to Washington, for the entire journey, there will be billions of data that will be flowing between the ground station, which is monitoring the flight in real time. Okay. This is possible with the synergy between GenAI and digital twins. GenAI enhances digital twins by improving simulations through predictive modeling and new content generations. It allows you automating design suggestions for optimization based, and it will be very much based on deep learning of data. That is the what comes from the physical asset to the digital twin, and deep learning of multi-layered neural networks. Accelerating fault diagnosis and quick repairs were even on flight. The benefits and challenges: enhanced efficiency, improved efficiency, enhanced safety, increased innovation, reduced costs, and faster design and testing cycles. The challenges are definitely data security, privacy, like data quality and availability of such data, integration, due to proprietary nature, they may not give the data to others. Now it's becoming open. Integration with the existing systems, regulatory frameworks for digital twin implementation, cyber security concerns, explainability of why you made the decision. That is GenAI, decision making process. GenAI will tell you why it made that decision. What is the reason? Okay, right. So to end my short 20-minute lecture, I will just please hold on for two videos. If the video does not play with the volume, please you can use the link and learn it yourself. Let me start the first video.
Sure, sure, sure.
Maintenance is one of the major contributors to aircraft operating costs. Flight delays and cancellations from unplanned maintenance cost airlines billions of dollars every year. Because of this, the minimization of operating costs and optimization of operational availability continue to be top priorities for airlines. How these airlines are going to achieve reduction in operating costs and improve the optimization of operational availability. Let's see this concept in daily facts in aviation. Digital twins, a state-of-the-art method of monitoring engines when in use, will help airlines achieve these aims. A digital twin refers to a virtual replica of a physical asset, like an aircraft engine, which can display how the engine is running to engineers on the ground while the aircraft is still in the air. Digital twins integrate Internet of Things, artificial intelligence, machine learning, and software analytics with spatial network graphs to create living digital simulation models that update and change as their physical counterparts change. These can then be linked to IT systems to help streamline and optimize maintenance processes and operational availability. To make this happen, engineers compile thousands of data points specific to each asset during the design and manufacturing phase of the engine. These are then used to build a digital model that tracks and monitors an asset in real time, providing essential information throughout an asset's life cycle, such as engine temperature, pressure and airflow rate. By implementing digital twins and creating a virtual model of the asset, organizations can receive early warnings, predictions and even a plan of action by simulating what-if scenarios based on weather, performance, operations and other variables, helping keep aircraft in service for longer. GE helped develop the world's first digital twin for an airplane's landing gear. Firstly, General Electric has a system based on digital twins and uses this software to administer and analyze data from wind turbines, oil rigs and aircraft they produce. The system they use for aircraft collects, per engine, all data of a flight between London and Paris. The data is transferred to a data center, where it generates a real-time digital twin of each engine. In this way, General Electric is able to detect potential defects or faults already during the flight. So, if a part of the engine is causing a fault, the personnel that is responsible for maintenance can have the replacement part ready at the airport where the aircraft will land. According to latest survey, companies that invest in digital twins will see a 30% improvement in cycle times of critical processes, including maintenance. This technology is keep improving to achieve enormous benefits in the future aviation world. Please subscribe this channel for more aviation-related videos. Follow us on Facebook and Instagram. Also post your aviation-related questions in the comments section. We will soon make a video for you. Happy.
Yeah. The next one is a 1-minute video. Just watch it. It's ANSYS digital twin.
Okay, sir.
Yeah.
With more and more aircraft in our skies, rising operational costs, and increased scrutiny of defense sustainment programs, the need to optimize operations and maintenance is critical. System failures aren't just dangerous, they're costly. The solution is simulation. Deployed beyond design, across the entire product lifecycle, digital twins are making engineering simulation more pervasive, with some analysts predicting up to a 30% improvement in cycle times for critical processes, including maintenance. To make sustainment and operations more affordable, with the integration of IoT platforms, collecting and managing data from thousands of sensors, ANSYS digital twin solutions are enabling a new level of predictive maintenance. Understanding the precise behavior of your assets in any situation and scenario, across both time and physical conditions, the ANSYS vision of pervasive engineering simulation is the only way forward. When you need to realize affordability, safety, and performance, when failure is not an option, you need to rely on ANSYS, celebrating 50 years of engineering performance.
I think that's what I wanted to convey to you. Uh, uh, Basically, there are n number of videos and a lot of information for you to learn yourself.
Yes, sir. Yes, sir.
And you know, the chat GPT today uh, can handle 10 power 12 data points scanning, but it can never reach the human brain level as of
Yes.
now, because human brain can scan 10 power 14. That means human brain is always 100 times better than the latest best chat GPT or generative AI product or Gemini. Okay.
Yes. Yes.
So because of the natural language processing capability and the time it takes using a neuron, whereas if you use a chat GPT to scan and get things done, I made this profile of this talk using chat GPT, but it would have taken enormous energy by bringing it from cloud servers data, whereas a human brain does it in a matter of seconds. Okay.
Yeah.
So it is you who have to put your efforts and innovate more and get into this wonderful area, and never have the opinion that Gen AI or the digital twins will replace human brain or human skills.
Yes, sir. Yes.
Yeah.
Yes.
Okay.
True, sir.
Right.
Thank you, sir. I ask let participants and people present there to ask any question if they have.
Yeah, and Selvi Gomes,
Yeah.
thanks a lot for this actually research tickling presentation.
Yeah.
So we have gathered only as our Bharat University students.
Okay.
Because of rain, we wanted to have it online. So many are in online, and some students are with us.
Okay.
I'll just ask them if they have any questions. Okay, Gomes,
Yeah.
thank you so much for
Thank you.
accepting.
Thank you. Thank you. Thank you very much. Thank you for the opportunity. I have to, because you initiated it.
Yeah, it's my
Yes.
pleasure. It's my
Okay.
pleasure, Gomes.
I have done DT and AI, Gen AI for the wind turbine sector. This is the first time I'm doing for aerospace.
Yeah, yeah.
Yeah.
Thank you.
Thank you.
Thank you.
Any questions, guys?
Any questions?